gadgets, these components, that are due to the Chinese tech industry.
Okay, so hi everybody. For the special foundation seminar, we have Anna Maria Cretu joining us from the University of Bristol, where she's a senior research associate. She also has a grant from the UK Arts and Humanities Research Council on human computers as instruments, which is also the title of her talk. Take it away, Anna.
Thanks, Ellen. So, thanks, Ellen, for inviting me. And thank you guys for being here and people in Zoom, presumably. So this talk is part of a larger project on human computers as instruments. It's a project funded by HRC. And today I'm going to talk about the downstream epistemic consequences for the methodology of science that come from treating particular types of scientific workers as scientific instruments. So I'm going to focus on the Harvard College Observatory human computers, roughly 1880s, 1920s, and the Bristol Nuclear Research Group scanners, roughly 1935, 1955. In both of these cases, the scientific workers were professionally untrained women hired to reduce and analyze data in astrophysics and nuclear physics. So here's the plan for today. I'm gonna present briefly the two case studies. Then I'll describe in a bit more detail what I mean by the scanners and computers instrumentalizations. I'll talk you through three frameworks I identified, which taken together can be reconstructed to explain the scanners and computers instrumentalization. And finally, and most importantly, I will explain what I take to be the primary epistemological consequences of instrumentalized scientific labor. So the last few decades of the 19th century marked a turning point in astronomy. This was in large part the result of the discovery and improvement of new and powerful instruments for celestial photography and the introduction of large staff of human computers to reduce and analyze the empirical data. Part of the work that the human computers were doing at the Harvard College Observatory was to identify spectral characteristics of stars, and this kind of like the patterns of the spectral types, and these were the kind of like photographic plays that they were analyzing, and their goal was to kind of classify to the first kind of like modern classifications of stars. I'm going to focus a bit less on exactly the kind of like scientific goals of the project of the Harvard College Observatory and more on the scientific work done by the computers themselves. So in particular, I'm going to focus on two of the computers, primarily for contrastive purposes. So I'm going to focus on Wilhelmina Fleming and Antonia Mori. So the reason why I chose to focus on them is because they exemplify the painstaking work undertaken by human computers. They are paradigmatic examples of computers who transcended their roles, and their employment experience and relationship to authority is markedly different. Wilhelmina Fleming joined the Harvard College Observatory in 1881, and she remained there throughout her career for 30 years. She was a former pupil teacher in her native Scotland and was acquainted with photography and the underlying photographic processes through her father's photography work. At the observatory, she was initially put in charge of copying, computing, and supplying copy for the Harvard photometry catalog, but her duties soon grew to include more tasks such as the examination, physical care, classification, and indexing of thousands of glass plates, of the ones I showed you before, training, monitoring, and planning the other computers' work, supporting the director of Harvard College Observatory, Edward Pickering, in managing the observatory's correspondence, editorial work relating to the observatory publications, the analysis of spectra, the identification of variable stars, gaseous nebulae, novae, Wolf-Rayet stars, and so on. And most importantly, she was quintessential in the creation of the first Harvard empirical classification of stars, the Henry Draper Memorial, which was a one-dimensional classification in alphabetical order, in the order of the strength of the hydrogen lines. This work was published, so the first installment of the Draper catalog was published under Pickering's name, and she was credited with the assistance in creating this catalog. The next kind of like scientific work that I want to focus on is Antonia Mori. She joined the observatory in 1888 with a BA from Vassar, one of the prominent women's colleges back then, where she obtained honors in physics, astronomy, and philosophy. So I'll just stop here in a sense and say that computers are defined as scientifically untrained women. We can kind of like see that this picture of computers as scientifically untrained sort of falls apart when you look into the details of each computer. So this would be the case of Mori, for instance. Anyway, at the beginning, when she joined the observatory, Mori was put in charge of the calculation of the spectroscopic binary Zeta Ursae Majoris meter, and her prescribed task was the analysis and classification of the spectra of the brightest stars in the northern hemisphere according to Fleming's criteria. Her actual task was she analyzed 4,800 photographs, which included 681 spectra of stars. In doing this work, she also discovered the second spectroscopic binary, Beta Aurigui. And most importantly, she observed previously unrecognized details in the spectra of stars. So fluidness, haziness, and distinctness. Each of these details contain important information about the stars. And in particular, this kind of extremely nuanced kind of like understanding of the spectra contributed, was essential to the development of the luminosity temperature relationship, and to her kind of like two-dimensional classification, which recognized the C properties of stars and was essential to the Hertzsprung-Russell diagram. So according to historians Dastan and Gallison, both women computers, so both Fleming and Mori held the title of human computers and were seen at the time as performing mechanical tasks that required no interpretation of or speculation, or at least that was the paradigm associated with the work of the human computers. However, even if this picture of them as mechanical computers is right, there are significant differences between the two women I was talking about. So Fleming, unlike Mori, did not complain outwardly and maintained cordial relationships with her employer, whereas Mori was when asked to hand over her work to a different computer, she expressed her dissatisfaction as her employer as follows. So she said, in a letter to Pickering, she said the following: I have had it in mind for some time to explain to you how I feel in regard to closing up of my work at the observatory. I am willing to have it in a satisfactory condition, both for my own credit and in honor of my uncle. I do not think that it is fair to myself that I should pass the work on to other hands until it is such shape that it can stand as work done by me. I do not mean that I need necessarily complete all the details of the classification, but that I should make a full statement of all the important results of the investigation. I worked out the theory at the cost of much thought and elaborate comparison, and that I think that I should have full credit for my theory of the relations of the star spectra, and also for my theories in regard to Beta Lyrae. Would it not be fair that I should at whatever time the results are published, receive credit for whatever I have in writing in regard to these matters. Will you not please write me your opinions about the matter? So as a result of
Just quickly, who is her uncle?
Henry Draper. So he's the pioneer of the spectroscopic method. Sorry, I should have maybe put that in the in brackets in there. So Henry Draper died fairly young and fairly unexpectedly, just as he was beginning his spectroscopic work. And his widow donated a significant amount of money to continue his work at the Harvard College Observatory. So then she also, to some extent, recommended Maury for the work, but at the same time, there's lots of kind of like historical evidence to say that the widow of Henry Draper was not in the cordial relationship with Maury and influenced Pickering's relationship with Maury as well. But that's kind of like a different. So as a result of her, writing, like requiring credit for her work, she, unlike Fleming, was the first woman to actually publish the classification under her own name. And I think this is the first Harvard publication that features the name of a woman worker. So although she did publish she published the spectra of bright stars under her own name, but the classification, the kind of like very important scientific discoveries that she made and the theories that she created were not given relevant epistemic authority, despite their kind of like novelty and significance for later developments in astrophysics. At the time, it's kind of like worth mentioning that at the time, some of the renowned astronomers of the time, so like Einar Hertzsprung, did recognize the merit of Maury's work and wrote to Pickering to say this is like exceptional, it's very novel and revolutionary, and one of the most important kind of like discoveries in Secchi's classification. But her classification was kind of like seen as convoluted and not really as important. So it wasn't given, it wasn't picked up. This had kind of like later consequences in a sense, as I'll argue later. But here's a quote from Doris Hoflet, an astronomer here at Harvard, who claims that if only Pickering had appreciated Maury's conclusions and acted upon Hertzsprung's remarks, a two-dimensional system would have evolved at Harvard 30 years before the currently preferred Morgan-Keenan and Kelman system. And sorry, there's a typo here. This should be Morgan. Just yesterday, I found this letter from Keenan to Hoflet, in which he says that Bill Morgan and I are interested in trying to piece together a more complete account of the beginning of luminosity classification of the stars. And of course, that means Antonia Maury. So it's kind of like you can see that sort of later on, her important discoveries were recognized, but this was 30 years later. So this, just before I go there, so this brief comparison, I take it to show that at least some of the computers transcended their prescribed roles, though there were also a lot of the computers that didn't. Even the computers who transcended their roles did so within particular restrictions. And even when computers produced important scientific work, they were not duly acknowledged. So a similar pattern occurs also in the case of the Bristol Nuclear Research Group, both in terms of kind of like the development of the project, so more kind of like foundational, but also in terms of the argument I'm presenting today. So similarly to the Harvard College Observatory, and for similar reasons, the research of the Nuclear Research Group marked a turning point in nuclear physics. This was in large part due to the discovery and improvement of new methods of photographing nuclear or photographic particle interactions. So Marietta Blau's work was foundational to the development of the nuclear emulsion method, and then Powell turned the method into a stabilized the method and turned it into a quantitative method. Similarly to the Harvard case, also the Nuclear Research Group marks the introduction of large stuff known as scanners to reduce and analyze empirical data in high energy physics. So the scanners, I'll hold on to that for a second. So the scanners were, and I quote here, I should have put a quote on the slide, were young women with no knowledge of physics who were hired to reduce and analyze the large amount of data obtained. Close quote, young women with no knowledge of physics, this is the quote. So they were hired to reduce and analyze the large amount of data obtained. Also, like a small photographic plate took about 60 hours of scanning of like a 4-inch photograph. So the responsibilities included the examination of the photographic plates with a microscope in search of specified typologies of events. So in Powell's words, the observers soon learned to recognize the tracks of mesons, and we found many examples of similar disintegrations produced at the end of their range. Indeed, the interest and liveliness of the observers was a crucial element in the progress of the work. They learned to distinguish by inspection the tracks of stopping mesons, which an experienced observer, which have particular characteristics that an experienced observer soon recognizes. And we took a great deal of trouble to help them to learn to interpret these events, the events they found, and to understand the significance of what they were doing. So more specifically, in their laboratory notebooks, the scanners noted the section of the plate, the coordinates, a brief description of the main track. They drew the tracks, and they took precise measurements and specified any additional tracks. They were also able to kind of like recognize whether the photographs were kind of like well-developed or not well-developed. So they were able to comment on the method as well and know that those were kind of like good, that was good data to analyze and so on. And it was two of the scanners, Marietta Kurtz and Irene Roberts, who first discovered the pion, or the kind of like specific interaction that's taken to be the discovery of the pion. But while and initially the scanners were they were given quasi-auctorial rights according to well, actually you can see here in the notebooks that, so this is one of the scanners, Isabel Powell, and in most of the notebooks they were able to write their names, and they featured as kind of like observers or micro observers, and in the published in some of the published material as well, it's noted that the observations were made by this or that scanner. But according to Peter Gallison, at some point during the investigations, their names were actively removed from the photographic plates and from official publications. So according to Gallison, they were demoted from discoverers to finders, despite the fact that their scanning skills were at least equal to those of many physicists. And in fact, you see in the laboratory notebooks that a lot of the time the observing work is done side by side by a scanner and a physicist. So for instance, Isabel Powell worked mostly with Occhialini, Cecil Powell worked with Margaret L. Andrews, and so on. So there's kind of like pairs of physicists and scanners. Okay, so I think it's like the computers, the scanners were seen as performing mechanical tasks that required little or no interpretation or speculation, or at least that was the kind of like paradigm, to some extent, the paradigm at the time, and I think the paradigm a bit later, and that's how we can like know of them as scanners and computers, and have at least the apparent impression that they work on like mechanical workers. But I think there is a clear sense in which both scanners and computers were instrumentalized in the sense of being treated as machines or extensions of scientific instruments. So I have in mind two senses of instrumentalization. So in particular, I think they were instrumentalized via assumptions of their prescribed roles, which involve trivialization of their cognitive and epistemic abilities. So in particular, kind of like lack of subjectivity, lack of speculative capacities. And they were also instrumentalized via denial of agency as knowledge producers. And I'll explain, well, actually, I'll explain now what that means. So it's kind of like worth noting that the instrumentalization notion that I'm using here has some features in common with notions of objectification that come from like feminist philosophy of science, but is distinctly different in the sense that it refers to treating humans as scientific instruments or extensions of scientific instruments. But in terms of similarities, I think there are like four main aspects of instrumentalization that can also be seen in cases of objectification. So in particular, fungibility of interchangeability of the people doing the work, denial of autonomy and self-determination. So none of the computers were in charge of their own work. Their work could have been taken away at any point, as we saw the case of Antonia Mori. They were kind of like perceived as lacking subjectivity and kind of like analyzing the data sort of mechanically, and they lacked agency as knowledge producers. So again, this is related to the kind of like control they had over the work they did. What am I doing for time?
7 to 10 minutes.
Okay, I think that should be fine. Okay, so I will go.
So the whole hour, so, however you want.
I identified three historical frameworks that can help us understand better the instrumentalization of these types of scientific workers. So the first framework is the institutional framework. This is a gender-based interpretation that I reconstructed from the work of Margaret Rossiter. So she, according to this institutional framework, the instrumentalization of scientific workers is the result of prevailing institutional norms on women's skills, capacities, abilities, accomplishments, and epistemic authority. So in particular, at the time, women were seen as being indefatigable, patient, more suitable for routine work, incapable of speculation, and inferior to men as discoverers or inventors. So, for instance, Frank Schlesinger, an astronomer related to the Harvard case, says in a letter that not only are women available at smaller salaries than men, but for routine work, they have important advantages. Men are more likely to grow impatient after the novelty of the work has worn off and would be harder to retain for that reason. So there's so this attitude that we see in Schlesinger's letter was kind of like dominated till much later. So there's in an alumni bulletin from 1927, we can see that basically women were taught to prove themselves more competent than men in work requiring infinite care and detail, and they are generally speaking more painstaking, more enthusiastic, and less apt to grow tired in meticulous, exacting labor than are men. So we can see this kind of like mechanical stance being carried on in the 20s, and this also implied that they were kind of like less creative, less able to theorize, and so on. And it's kind of like interesting to some extent how these attitudes this kind of like cultural attitude dominant at the time kind of like permeated the way the workers were thinking of themselves. So I kind of like listed all the different things that Wilhelmina Fleming was doing at the Harvard Observatory. But in 1901, which was kind of like close to the time where she was even given a more kind of like a better title as curator of astronomy, she still writes the following. So March 1st, 1900, in the astrophotographic building of the observatory, 12 women, including myself, are engaged in the care of the photographs, identification, examination, and measurement of them, reduction of these measurements, and preparation of results for the printer. The measurements made doesn't matter. So from day to day, my duties at the observatory are so nearly alike that there will be but little to describe outside ordinary routine work of measurement, examination of photographs, and work involved in the reduction of these observations. So it's like highly speculative, but one could also think that this them understanding the work as routine would also be related to the fact that they would not receive due credit for the kind of work they did. So this is one of the frameworks that we can use to better understand instrumentalization, but I don't think it goes far enough because so like a gendered lens is not sufficient to explain instrumentalization, because both in the Harvard case, throughout the extent at which the period in which computers were hired, some of them were better recognized than others. And also this kind of like framework does not extend very well to the Scanners case, where you had like women physicists working and being recognized and published at the same time as the Scanners work was happening. So I think we need to have an additional complementary framework to understand instrumentalization. And this is can be reconstructed from Stephen Chapin's work on technicians. This is a role or function-based interpretation, which also explains the composition of the labor force, but attributes the instrumentalization rather than to gender norms, to prevailing norms on technician skills, capacities, abilities, accomplishments, and epistemic authority. So Chapin knows that technicians' observational and representational labor was transparently subsumed into the workings of the instruments without attribution of assisting human agency. It was found. So you can see in a sense how this framework also lends support to the fact that these types of workers were seen as sort of extensions of scientific instruments. And there's kind of like anonymizing language that further supports this framework as well, which I won't go through in the interest of time. Okay, so the last framework, which I'll briefly mention, is the epistemic injustice framework proposed by Miranda Fricker, which is a good framework to understand, in particular, the kind of like consequences of instrumentalization for individual workers. I will not give any further details on this framework in particular, because I'm mostly interested in the remainder of the talk in the consequential harms for the methodology of science that come from the instrumentalization of the workers. So I want to spend the last few minutes to tease out some of the main epistemological consequences of instrumentalized scientific labor. So the first consequence relates to potential delays in scientific progress due to unacknowledged theoretical discoveries of scanners and human computers. So, for instance, Antonia Mori's luminosity-temperature relationship, as I explained earlier, and its importance in devising a two-tier classification of stars languished for nearly 30 years before it was rediscovered by Morgan, Keenan, and Kelman. So I think there's kind of like, there's clear evidence that instrumentalizing scientific workers can lead to this kind of like delays in scientific progress. The second consequence I want to talk about relates to the to methods evaluation. So once again, the case of Antonia Mori is relevant here. So her methods, which were rooted in kind of like painstaking spectral analysis, and which was seen as specifically computer work by which she discovered this very important salient patterns, gained no uptake. So the spectral method on its own, as opposed to theoretical methods, was not deemed likely to elicit important theoretical insights, and the theory that went with it was dismissed as well as being too kind of like rooted in computers' work. I think this holds further implications for who has epistemic authority and the basis on which we attribute epistemic authority to scientific workers more generally. The third consequence relates to problematic biases, which lead to the introduction of artificial distinctions. So in particular, the finding, discovering distinction that Peter Gallison identifies, I think it has important implications for what we count as empirical theoretical discoveries and can potentially lead to a reconceptualization of scientific discovery. And I have here some kind of like important questions that we can ask in relation to this particular distinction. Finally, the fourth consequence relates to historical distortions that can lead to omissions, deletions, and deletions from formal or official records. And I think such distortions give rise to flawed narratives and simplistic myths about who produces scientific knowledge and how scientific knowledge is produced, particularly when we're talking about big data science and experimental science. So, okay, I'm gonna conclude with a main, kind of like the main lesson that I think is the main takeaway lesson and the main thesis I argued for, particularly the idea that downstream epistemic consequences of scanners and human computers instrumentalization impact not only the individual, but the methodology of science. So what I take this case studies to show is that while credit and recognition are important, there are also kind of like downstream consequences that we should care about if we care about the epistemology of science. And finally, the work that I've been doing here, and that's the work that I'm doing in the project. I think it's important to know that it's got kind of like three different dimensions. So there's a forward-looking dimension, so philosophical and normative assessment of epistemic work and epistemic injustice within large scale. So it's got the work, it's got implications for philosophical and normative assessment of epistemic work and epistemic injustice within large-scale collaborations, big data science, and citizen science. There's a backward-looking dimension, so a better understanding of scientific, it can lead to a better understanding of scientific processes of knowledge-making. And there's a historical justice dimension. So this kind of work, I think it's a timely addition to conversations on the historical invisibility of marginalized groups in the history of science. Okay, thank you.
Wonderful. So we have about maybe 45 minutes for questions. So if anybody on Zoom has a question, Anika or Ramesh, feel free to speak up or raise your hand and I'll call you, but otherwise, questions in the room?
I have a bunch of questions, but you should go ahead because if you have some, because I speak to you quite a lot afterwards, so I don't want to.
I've got a simple question. Let me start with that. So I mean, I found what you said about Laurie being the one to recognize there was structure in the data that she was set to observe or analyze, that people who told her to instructed her to analyze it didn't realize. Really interesting in the sense that I guess what it shows is that they underestimated the method itself, and it was only the fact that the person conducting the method obviously wasn't a computer, because one of the kind of essential differences is self-reflexivity. And so the fact that as a scientist she was able to reflect on the nature of what she was doing and understand that the method was more powerful and could glean more data than was appreciated seemed like a fundamental breakthrough. So I mean, it's very much part of a piece of what you were saying, but it seems like there's a specific like methodological reflexivity that you get from thinking about human computers as humans that you lose by thinking about them as literature.
So that's a kind of like good observation to make, and I think so. The human computers as instruments work is mostly predicated on the work of Daston and Gallison as idea of mechanical objectivity. I think up close in some of the cases I'm talking about, the framework breaks down because as I showed, like, so there's lots and lots of variation between the computers and the scanners. So these are people who were employed over 2 to 4 decades. And that each time there were a dozen or more than a dozen computers or scanners, and each of them had different kinds of training and were doing different kinds of work, right? So some of them did a bit more mechanical work and didn't have the kind of reflexivity that you were mentioning. But in fact, in the Harvard case, most of the people hired were drawn from the women's colleges. So they already had, they weren't professionally trained in the sense that they didn't have more than an undergraduate degree, but they did have a significant acquaintance with the scientific methods.
Yeah, one of my questions was related to what Karen just asked, and I was kind of wondering if you wanted to see a little bit more about the devaluation of methods, you know, because I think that's a really important, in some sense, epistemic consequence of you know, the project. And you know, I mean, it strikes me that what you're saying has a kind of import for philosophy of science more broadly, insofar as it seems like we tend to attribute a lot of importance to scientific theories and not as much to the kinds of, you know, methods that are used, and in some sense the kind of like know-how and, you know, expertise that individuals might have as a result of the particular perspective that they have on the world, like, is really something that comes true, right? In this kind of methodology that some of them, like Antonia Mori, for instance, as you explained quite well, had managed to develop. And I mean, do you think that that's something that we should acknowledge just sort of much more broadly in philosophy of science in some sense, and that would link well to the literature on values in science, perhaps why?
So let me start with the end. In a sense, I'm not entirely sure how this would, I mean, if by the kind of like how it would tie to the literature and science and values, if you by that you mean kind of like a reevaluation of how we think about scientific discovery and so on, then yes, definitely. But I think there's like what's worth mentioning in a sense. I think there's kind of like two, in a sense, parallel but similar, like parallel in terms of like origin and field and so on, debates about this or attitudes about this in terms of the communities of physicists themselves were to some extent divided in terms of like theory and experiment. And you could see this like the case I was talking about with Mori, you can actually see that again in the case of Cecilia Kaposhkin, who made one of the most significant discoveries in astronomy, namely that stars are made of mainly of hydrogen and helium. She did that through sort of computer methods, and she was discouraged to publish her results. And then an astronomer that came from kind of like a theoretical standpoint made the same discovery 7 years later, and was for a very long time known as the discoverer of Payne's discovery. So I think there's this attitude sort of persists in the kind of like physics or like in the scientists camp, but there's also like I think a disservice that has been done by philosophers, particularly philosophers who have dismissed the contribution of who have dismissed the context of discovery, right? So a lot of the philosophical work on discovery has mainly focused on theory and on kind of like justification and confirmation and so on. And we haven't looked nearly enough at scientific knowledge making in the experimental context and what's involved there.
Thank you. This is great. So, so in some of the materials you showed, you can kind of like see how the patriarchal social order is really struggling to draw a sharp line between what they want to classify as the feminized clerical labor and what the intellectual scientific work. And you can kind of follow the actors' categories that appear in the documents, things like scanning or computing or classification. And then a lot of the documents also analysis, like being conceived as on the feminized clerical side, and terms like theory and discovery on the other. And I think that's why that letter by Mori that you found with the archives is so powerful. It's like, oh, this is my theory, right?
Definitely.
Like the use of the term theory there is really like kind of transgressing that classification. So like in practice, all of those various activities are really like all of these categories are kind of porous, right? And I guess my question was like for a project of epistemic justice, like would you be more hopeful in the direction of like trying to revise categories like theory and discovery and their distinction from just mere analysis in a way that would address the kinds of the epistemic and political problems that appear in these cases, or to somehow do away with these distinctions altogether?
That's a very interesting and fascinating question. So I don't know how well you can see this photo here. So a few days ago, I've been spending the last week at the Passaic Library, just like looking through the primary archival material. And they have this display which has the women computers. But what fascinated me in a sense is that the word computer is put in inverted commas. So in a sense, so this ties back to your question in a sense, because you kind of like it's kind of like hard to say in a sense from the archival material whether when the word computer started to be used for these scientific workers. So I found explicit evidence of the word being used in 1915, but not prior to that. So in a sense, there might be, I think what we need to do before we consider any revision of the concepts is to try and understand, like zoom in a little bit more in this like big periods of where the scientific workers were hired and try and understand what kind of work they did. So it may be perfectly plausible to some extent that there are distinct periods of the work in which in which kind of like the work is more innovative and then routine and more innovative and more routine. And then you have this kind of like peaks and so on, where just zooming in and understanding that would not necessarily necessitate the redefinition of the concepts. Because I think some of them are good enough, precise concepts that we use in scientific, that they refer to particular scientific methods, and we still use in scientific context today. So I think it's just, before we consider that, we just need to look at the work more carefully.
Thank you.
Okay, I have two questions, but I'll start with one that's connected to Rodrigo's question. So I was kind of thinking, like, there's a sense in which the people who hired these women wanted them to be computers and were disappointed perhaps when they did more. Yeah, so it got me thinking, like, maybe this is more of like a hopeful descriptor where they were like, but then I take it kind of what you're saying is sometimes they were doing that, but I wonder if it's really actually possible to look at similar data for many years and not start to see trends and structure, etc., in a way where like the theory latedness just has to emerge as you continue to analyze more and more data. Like at first it might be the first time you see the data, the first year or whatever. But as you see it more and more, you're like, this doesn't look like that, but already you're doing structural kinds of reasoning. So
you're doing inferential reasoning to some extent.
Exactly. In a way that like, so just the hope of hiring people as computers is just flawed from the get-go.
Definitely. So I agree. I have two kind of like things to say about that. The first is in a sense that at least in the Harvard case, Pickering's idea was to kind of like, because this was like a very new method, and his idea was that, and there's like specific quotes which I have in a different talk, but where he saw his role as just like amassing the data, classifying it, and then leaving the theorizing for later generations. So in a sense, you can kind of like see that in, the people who were hiring, I think that was exactly Pickering's expectation to some extent, that they should abstain from theorizing and they should just do what they were told so that they could like go through all this, organize all this data, right? I think that given that he was hiring, he knew the qualifications of these women, and some of them were recommended for their kind of like scientific merits and so on. It's a bit naive to think that, as you said, that you wouldn't try and understand the things that you are working with, right? And I think in the case of the scanners, the quote I've given from Powell shows, in fact, that they weren't kind of doing that. That they were explaining to the scanners what the work was done and so on. But there is I think there's another kind of like plausible interpretation in a sense that the scanning and computing kind of like stance is precisely that you wanted to have more like mechanical means of analyzing the data that would in some sense objectify the data. And I think you see that later on in the bubble chamber programs and so on, where the scanners didn't have almost any autonomy and they weren't even told what the work that they were doing, what was the goal of the work that they were doing. You said you had two questions.
Yeah. I'll ask my second one. So it's kind of, it's like not really a question, but I'm wondering if you can say more. So I was thinking about this epistemic justice framework, and I was thinking, this seems right, but also the women at this time were going to face all sorts of epistemic injustice in like all sorts of areas of their lives. So then I was thinking, maybe if they had seen them as requiring scientific backgrounds or merits or qualifications, some of them did have it, but if they required that, in fact, it would be more unjust in a sense. because I'm thinking, if you demand of somebody that they have some kind of scientific qualifications, and then you give them this data that they have no autonomy or any like rights over, that seems wrong, especially wrong. And so I'm wondering if it would have dissuaded certain people from applying to be computers or scanners that actually benefited a lot from having that role. I mean, given Harvard's first PhD in astronomy, first woman PhD in astronomy didn't come until 1925, maybe this was the closest they could do to having a real scientific impact. And so I don't know if you have thoughts on
Definitely.
this.
So that, I mean, like that was like a lot of the women were doing this kind of work. They could have done like better paid work as like in a lot of areas where there was already where there were jobs for women.
Mhm.
But this was like the one of the only types of scientific
Right.
work that they could do.
Right.
So they could do like basically teaching and this kind of work. And that was the only kind of work that they were doing. But I was thinking actually just over last week, and especially kind of like, because I've been reviewing a lot of material to do with Antonia Mori. And like you can clearly see that she pursued scientific career throughout her life, and she was kind of like in and out of the Harvard College Observatory. And I was thinking in a sense that had she had the opportunity, she would have, and the encouragement, she would have most likely have done, had pursued like a professional scientific career. Right. So I remember also like reading about Dorit Hoflet yesterday that and you can find this, I think, in some of her recollections, that she and a lot of other computers who came later were in fact, if they had like a scientific kind of like interest, they were encouraged by Harlow Shapley to pursue a PhD once that became possible.
Mhm.
Right. So I think it's, in a sense, it's kind of like interesting to think about I think it's interesting to think about epistemic injustice in this kind of context, because what I want to focus on and why I'm focusing more on the epistemic consequences for methodology of science, I take that to be distinctly epistemic, right? But I think there's like, if these are the kinds of cases where there's lots of injustices done to women, some of which are distinctly epistemic and some of which aren't distinctly epistemic, right? And some of the computers were perfectly happy to just do kind of like clerical work. And that, that's completely fine.
So I was wondering if you could say a bit more about the relationship in your view, right, between those three frameworks that you drew from to analyze the epistemic consequences downstream. Because I was not really clear in some sense about why you sort of separated them. I mean, I think it's useful analytically to get them, separated like in this kind of artificial way, but I was just kind of
I think they're
wondering.
they're complementary. So I think
that
you can only understand instrumentalization. I think you can only have like this more nuanced understanding of instrumentalization if you take them together, because it wasn't just a gender thing. It wasn't just a functional thing, and it wasn't just an identity-based thing, right? I think there were like there's lots of different elements of the institutional, sociocultural aspects, and to do with distinctly with like the type of person, so like more identity-based reasons why in different cases the computers were instrumentalized. So you have to they're meant to be taken together, the three frameworks.
No, I get that. It just sort of, I was kind of wondering if, the sort of like functional framework was such that, the sort of gender aspect was kind of like a subtype thereof, where it's like a function, of that in some sense.
Well, I think,
but
so these frameworks, I sort of reconstructed them from that, because there's not a whole lot written about human computers and scanners.
Yeah.
So the functional framework is really taken from Stephen Shapin, who reflects on 17th century technicians and kind of like sort of big data there, right? So like it's more trying to understand how collaborative science works and how people get to be credited or not in collaborative science. And at least in some cases, the technicians were seen as skilled but not knowledgeable. So this is kind of like a sort of awkward distinction in a sense, but it's meant to be in a sense like the know how and know that, or like the empirical dirty work and the theorizing work. So it's not as such gendered, that like that framework doesn't necessarily imply a gendered element.
Oh, of course, yeah, of course, but I mean, you know, if you have this kind of framework, right, I guess there are different ways of, you know, parsing it, like, one case of it would be the gendered case. That's kind of what I'm kind of curious about, whether you have a view on that, or whether you think you kind
I
of.
just think it's
don't
the
need
role,
to
the
worry
role
about
of
it.
the, I think it's, so I think in the functional framework as I had it in mind is more to signify the hierarchical aspect of the institution, the projects, and to delineate basically the status
That's
of a
what-
person within the collaborative project.
Okay, that's really helpful, thank you.
I had a question about about instrumentalization as like actors, like as something that might also come from the actors language. And so like in the presentation, instrumentalization like is a it's like it's part of your analysis. Like in some like contemporary astronomy, you know, at least electronic computers will sometimes appear in the language of the scientists as like as instruments. Like people will say, you know, the algorithms are part of the telescope, or the computers are part of the telescope. Yeah, I was just wondering, like, would the conception of human computers as instruments also appear in any of the archival materials and like the language of the actors themselves?
So this goes back a bit to your earlier question, in a sense, like I've been in the Bristol case. They are never called scanners in the archival material, as far as I'm aware. So if you look at all the laboratory notebooks, they're called observers or micro observers. Same in the personnel files. In the Harvard case, I have been having a very hard time finding employment records or personnel files or any kind of like material where the status of the person would be specified. What I did find were some letters, but again, from 1915, this practice started in the 1880s or a bit earlier. So in 1915, there's a letter from, I forgot the name of the woman. There's a letter from a woman inquiring about the vacancy, about the computership. And in his reply, Pickering says that we are in need of computer work, but we don't have funds. So certainly the term started to be used at some point. I'm not sure if it was always used by the actors themselves. And I don't think they were, so in some cases it's clear that they weren't. I remember now, there's a letter from Ida Woods, who was like one of the first computers. And she writes to Pickering to ask, so when some fellowships for women become available, she writes to ask whether her work would count towards the fellowship. And she describes the work that was known to Pickering, and she described it as scientific research, and says, I know how interested you are in scientific research, and would you, so I think some of them were just taking themselves to do scientific research and to do observations, and that would, and they would have used the word observer. So I haven't come across of them themselves sort of referring to themselves as computers.
I see. Yeah.
So as you saw, there was some reference to at various points them thinking that they were doing routine work.
I see. Yeah, I get my question go more in the direction of like if there was language about like the computers being part of the instrument, like in
well.
yeah,
Like I
yeah,
think it requires bigger,
yeah,
like more complicated instrument, because in this case, it seems like you get your plates and then you.
Well, there is this language here where you basically have sorry, where is it? It's like in Powell. Oh, I don't know, I have it. Sorry, it's actually in one of the frameworks. Here or here? Here. So there is this kind of language in the Bristol case which occurs in some of the letters. So for instance, there's basically they're saying they name all the physicists and say girl for scanners, or they have 3 more microscopes and 3 girls. It's like that we need 3 more microscopes and 3 girls, as if they're kind of like the same kind of category of things.
Yeah.
And then you have more instrumentalizing language. In the Harvard case, I only came across recently where they were talking about kilo hours as the work, is kilo hours and kilo girls. So basically the work was measured in kilo girls.
Oh, wow.
So I haven't found the hold on, I haven't found the exact primary material for this, but there was a talk at Harvard. So
Here,
what was it?
Go back up.
yeah, one more. Yeah.
There you go. So there was this
Oh.
kind of language used, I think in the time of Shapley, but I think it was, I mean, like the implication was that it was just kind of like, that it was possibly used, jokingly just between, but certainly usually just between the scientists themselves and not like referring to the computers or the scanners. So there was some problematic anonymizing. There was certainly a lot of like problematic anonymizing language used in personal correspondence between the scientists.
Talk about the objectification.
Yeah.
Yeah.
That's bad.
So that's what I kind of like have
Who
to.
gave the talk?
Yeah.
Doesn't say who gave the talk. Oh, it does. There you go. Led by I'm not sure it was, but it did,
Yeah, it looks like a display maybe.
Yeah.
Oh,
It was like an exhibition or something. Yeah. I only came across this recently, so that's why I'm saying I haven't come across any primary data in which, for instance, one of the women would say, I've been hired as a computer, or I've been doing computing work, or yeah. But I think there is problematic the use of the word computing, and particularly in the case of the scanners, the use of the word scanning for what they were doing is itself gendered language and kind of like instrumentalizing language. Because what they were doing, and specifically because they were doing it side by side with the physicists, they were doing observing. They were observers and they were doing observing.
I mean, there were
So,
researchers.
yeah.
What you call now as research.
I don't actually hear. Yes.
Well, we're at 3, so I think we can end here. Thank you so much. Thank you.